This morning I'm going to show you how to do how to build the bone graft models just on the using the physical system and basically laying the bone graft on the system, so you can recognize a one-to-one correspondence between the bone graft model and the physical system. So let's take a look at this electrical system that you see in there and begin. Okay, so what we're going to do is, the first thing we're going to do is to put the one junction for each one of the currents here. So we put the one in here, we put the one over here. This is the current I1 here, and this would be the current I sub 2. And that's the first step. Second step is to attach the elements that experience those currents. So on this one, obviously, this SE with value voltage here, this is attached to this. This one is an I element with value L, assuming L is this, and R is here, and C is over here. On this one we have C with value C, and that is that step. The next step is that we establish the current differences. So we do that with a 0. So I1 minus I sub 2. We can put a one junction here to indicate that, but I think we could also simplify it a little bit. This would be I1 minus I sub 2 is this here, and then this is the R element over there with value R. Okay, let's practice the assignment of the causal marks also. That's important. You know that step is done by the software, by CAMG, but you need to know what CAMG does. First we assign it to the source, then to the I in integral form. If this sets one flow into the one junction, makes this like that, and then we assign it to the C in integral form also. That requires that this would have a flowing like this, and that makes this 0 with the effort here, this to be like this. CAMG would do this and also would number this, so that's not a problem. So I think what we need to do is we'll try a different example, perhaps the hold on for a second. I'm going to draw a different one now so that we can practice some more. Okay, so let's just do this other example, similar to this, but with some variation that indicates a little bit more difficulty. So in here we're going to put a C element over here, and in here we'll put an R element. Here we will do a C element, and then in the middle we'll put an inductor over here, and then we have this here. Okay, let's give it a try again the same way. So in here we go, and with a different color, I'll just use the 1 over here for the I1, another one I sub 2 like this, and then attached to those currents. The elements that C, this would be with value B. This other one would go with a C element with value C over here. This, so it doesn't. This one in here is another C, like this, with value C sub 2, let's say. If this is C sub 2 and this is C sub 1. And then this one would have an R element over here with value R sub 1. You see, and then we have to deal with what's in between, which is this I element that sees the difference between this. We create the difference between those two. This I element sees the difference, so we're gonna put the I element over here with value whatever it is, L over here. So that's my bond graph model of this other circuit, and let's practice against the causal assignment to see if everything is okay. This one will be like this. We're going to put the let's see, here we have this in integral form that makes this to be like this, and the moment we force this makes the 0, all of them to be like that. And if you put the C in integral form, you get the R this way, and the causal marks completes perfectly well. So that is one. Let's give it a try now to a different example where I think we will experience a different challenge in here. And so we are going to draw a new example here. I'll just use to be consistent with the colors that we're doing. Let's see if we have the same level of difficulty or more. But let's say we have a circuit where we have this kind of thing, and then we have a element over here like this, and you have this element down here would be like this, and we have one that goes as an inductor like that, and then we have another one that goes like this. Alright, we're going to apply the same procedure, and let's see how we do with that. In here we go and put the 1 in here, we put the other one over here, and this is I1, I sub 2, and I sub 3 in here, and this is the voltage source, which would be a source of effort with value V. This I think we're gonna say R1, R sub 2, and this is R sub 3, and then you have this would be C. So in here we go and put this as R in here with value R1. This other one also C is the current with value R sub 2. This R element C is this current here, R with value R sub 3, and this other one would be a C element with value C. And in between these two we learned that using a zero junction, remember I originally told you just put a 1 for that, and then you put the next element, Now we're simplifying it a little bit. We know that this is I1 minus I sub 2, and then you can directly put the I element in here with value L1, and this would be L sub 2 in here, and then this other one you do it the same way, and we will have the I element with value L sub 2. Do you see? Now 101 correspondence with the physical system. And so now you have this, let's do the causal marks. I would encourage you to enter this one into the computer, because here's what you will see. Okay, you put this over here as a effort to the source. You put it here to the 0 and nothing happens. You put this one to the other 0 and nothing happens. And you put this in integral form for the C and nothing happens. If you put this into the CampG software, it would do what I just did, but it's going to show you red marks through all these loops in here, which means that the equations of this system are much more complex because they have algebraic loops that need to be resolved. At this point, I will not give you to solve on your own those kind of systems, but I want you to know that if you connect things a certain way, you might not be able to solve them explicitly. You need other mathematical techniques to solve this. And a circuit that is as simple as this one, you have, there's a problem right here. If you enter it into the CampG software, the causality will not complete. Has anybody done it? Yeah.
I've done something like this, and I just encountered this causality.
So now you can see that in our system here, we have a situation where the causal marks don't complete for the whole system. You know, these are okay, but these ones don't complete in here. In other words, this is a problem, and if you put it into CampG, all this is going to be red. So one way to solve this is to introduce a small element that could actually determine the causality in here. And usually on the ones, if you do it, I'm going to keep this color so you can see that it's a different. If we add an I element over here, a small I element, you see what happens? It determines the flow to the 1 and makes these ones like this. You see? And then this is determined here, this one is determined here. The 0 needs an effort, so it makes it like this, see? And that sets the flow to this one, and that makes the other flows out like that. And in here you have two flows to the 0 needs an effort, see? And then in here you will have a flow, and then this completes. Give it a try on your computer and see what you get. If we put an I element over here, we will fix the fact that the causality did not complete. Of course, it would be like a parasitic element, and it will have to be a very small so that they won't influence the system, but it fixes the derivative form. It fixes the algebra loops, excuse me, and the causality completes.